Alrighty, we're going to finish up section 4.1. We've got the integral of some trig functions, but it's not all 6 of the trig functions. It's just specific combinations. So we have the integral of sine x, and if you think back and you say, what do I take the derivative of to get sine? Well, the derivative of cosine is negative sine, so the integral of sine x dx is negative cosine x plus c. What do I take the derivative of and get cosine? Well, that's sine. So these two, you do have to think about how that negative works. What do you take the derivative of to get secant squared? Tangent x plus c. What do you take the derivative of to get secant x tangent x? That's secant x plus c. Whose derivative is whose derivative is cosecant squared x? Nobody's. But the derivative of cotangent is negative cosecant squared x. So that's why the integral of cosecant squared is negative cotangent x dx. I'm not saying integral each time. I'm trying to start with the derivative and let you see what do we take the derivative of. If I take the derivative, what do I take the derivative of to get this? So the integral of sine x is negative cosine x. Last one. What do we take the derivative of to get this? Well, that is nothing, but the derivative of cosecant x is negative cosecant x cotangent x. So the integral of cosecant x cotangent x is negative cosecant x plus c. And oops, I did a little dx here, and I meant to do a plus c. So I will give you these on a sheet, but if you needed to memorize them, then you think, well, if I take the derivative of sine, what do I get? The derivative of sine is cosine. So then I would know the integral of cosine is sine. It's only when you've got those that give you the negatives that's a little bit more tricky. Okay. So if I were to do the integral of 2 sine x dx, we'd probably bring the constant in front of the integral. And what do you take the derivative of to get sine? It's negative cosine. Oops, I forgot my 2. Alrighty. Now sometimes derivatives are not in the right form, and it's not simply just moving exponents. We had one similar to this, number 21 for homework. The first thing I'd like to do with this is rewrite that denominator with power. And then I'd like to do I love math. So that becomes x over x to the 1/2 plus 1 over x to the 1/2 dx. Well, when I divide like bases, I subtract these exponents. So 1 minus 1/2, or 2 halves minus 1/2, is 1/2. And this one, just need to bring that up to the numerator and make it negative. And now it's x to a power, so now we can use the power rule. So x to the 1 more is x to the 3/2 divided by 3/2 or multiplied by 2/3 plus x to the 1 more is x to the 1/2 divided by 1/2 or multiplied by 2. And I'm okay if you leave it like that. Now this one is a little more out there. What if you have sine x over cosine squared x dx? Well, there is no quotient rule. There is no product rule. So we've got to try to rewrite this so that it fits one of our integral of trig function rules. And it sure doesn't fit anything right now. And we might remember that cosine squared is 1 minus sine squared. But, and that might work if we were to do that. But the way the book does it is they rewrite it as sine x over cosine x cosine x. So then that's maybe we put a little plus 1 here. And we can do that times that. My dog is barking like crazy. So it's like that. Sorry, I'm distracted by my dog. Sine x over cosine x is tangent x. And 1 over cosine is secant x. Oh, just a little rewriting, and then it fits this formula right here. So it's equal to secant x plus c. So a little bit more thinking, more trig identity thinking things here. Example 7. Just run through these 4. The integral of 2 over the square root of x dx. We already saw how to handle that earlier. We'd make that 2x to the negative 1/2 dx. And then that's 2 times x to the 1 more, divided by 1/2 or multiplied by 2. So that's 4x to the 1/2 plus c. B part. What if we have the integral of t squared plus 1 squared dx? Well, there's no chain rule for integrals, so I can't do that. My only choice is to expand this. Either write it down twice and FOIL it, or just expand it. So it's t to the 4th plus 2t squared plus 1 dx, and then we can take the integral of each little piece. So t to the 5th over 5 plus 2t to the 3rd over 3 plus t plus c. C part. What if you have the integral of x to the 3rd plus 3 over x squared? This is maybe the second time we've seen one like this. We would try I love math on it. And that would become the integral of x to the 3rd over x squared plus 3 over x squared. That simplifies to x plus 3x to the negative 2. Now they're both x to powers, so it's x squared over 2 plus 3 times x to the negative 1 over negative 1 plus c. So that's x squared over 2 minus, I think I will make that become 3 over x to the positive 1 plus c. Make sure you see what happened there. D part, last one of these. The integral of the cube root of x times x minus 4 dx. Oops, I forgot the x. Let's rewrite that as a power. And then let's distribute, because there is no product rule. When you multiply like bases, you add their exponents. So 1/3 plus 3/3 is 4/3 minus 4x to the 1/3 dx. You notice sometimes I have to start adding parentheses because I need everything that's being integrated to be grouped together. So if it's not already a product and it became 2 separate terms, I need to group them with parentheses. So now I can integrate this, and it becomes x to the 7/3 divided by 7/3, but we would rather multiply by 3/7 minus 4 times x to the 4/3 divided by 4/3 or multiplied by 3/4 plus c. 4 times 3/4 cancels the 4's. So 3/7 x to the 7/3 minus 3x to the 4/3 plus c. All right, now we have a new type. Sometimes we want to be able to find a particular solution when they've given us an initial condition. So let's say it says, I'm going to reword this a little differently. Find the particular solution for, let me look and see how the homework does it. Find the particular solution that satisfies f prime of x equal to 1 over x squared if f of 1 is 0. Okay, so what we would do is they're wanting us to integrate this to get it back to f of x. So we're going to integrate both sides, and when we integrate, we do it with respect to x in this one. When you integrate a derivative of f prime of x, you get just f of x. And when we integrate 1 over x squared, let's just remember that's x to the negative 2. It becomes x to the negative 1 over negative 1 plus c. Let's clean that up a little bit. That's negative 1 over x plus c. Now, that's a general solution. We want the particular solution that satisfies this initial condition. And this is the general solution because it's good for any constant, but we want the particular solution where it's not just a c, we want the particular c value. So we're going to take this initial condition, which gives us an ordered pair. If f of x is 0, then x is 1, and f of x is y, so y is 0. So that's the ordered pair 1, 0. We're going to plug it in. F of 1 is negative 1 over 1 plus c. We know that f of 1 is 0, so we'll put a 0 equals negative 1 plus c. So when we add 1 to both sides, which I'm running out of room, we find out that c is 1. So you plug that back into your general solution, and you learn that f of x is negative 1 over x plus 1. And this is the particular solution that satisfies our initial condition. Alrighty. I need to do example 9 too, I believe. Example 9. A ball is thrown upward with an initial velocity of 64 feet per second with an initial height, that's our s sub naught, of 80 feet. Find the position function giving the height as a function of the time. Okay, so I wrote it this way because this is how we wrote it in the previous chapters, but the initial velocity might have been written this way. And the initial position, that initial height, might have been written this way. Okay, find the position function giving the height as a function of time. So we always start with the highest power of the derivative. So if v of 0 is 64, then since velocity is the derivative of position, that means s prime of 0 is 64, since v of t is equal to the derivative of position. So you start with your highest power, and you integrate both sides. Oh, and you have to, we kind of have to know that acceleration due to gravity is where we would start, because they are throwing the ball up, and what goes up must come down because of gravity. So acceleration is negative 32 feet per second, feet per second squared on Earth. And this experiment is happening on Earth. So we need to start with the highest power, and just remember also that acceleration is the second derivative of position. So we're going to start with s double prime of t equal to negative 32 dt. Then we are going to integrate both sides with respect to t. That when you integrate the second derivative, you get to the first derivative. And when you integrate negative 32, it becomes negative 32t plus c. Well, we have an initial condition dealing with velocity, which is our s prime of t. We know s of 0 is 64. So s prime of 0 equals negative 32 times 0 plus c. And we know s prime of 0 is 64, so we put the 64 in. Negative 32 times 0 is 0. That means c is 64. So you can go right here and change that c to 64. Let me delete a little bit. So now we're at this function, negative 32t plus 64. Well, we have another initial condition. We know s of 0 is 80. So if we integrate both sides, if you all need me to do this for you again Wednesday, you can ask. When you integrate the first derivative of s, you come to s. And when you integrate this, it becomes negative 32t squared over 2 plus 64t plus c. That's negative 16t squared plus 64t plus c. And we have an initial condition of s. It's that s of 0 is 80. So s of 0, plug in zeros for the t's. S of 0 is 80, so put 80 here. 0 plus c. So 80 is c. So then we go to this formula right here, and we plug in our c value. So s of t is negative 16t squared plus 64t plus 80. Now keep in mind, we could have gotten that using pre-calculus a long time ago. Don't be mad. We could have gotten that a long time ago. We know the formula because we used it earlier in this class also. We know the position function formula. I think it's 1/2 gt squared plus v naught t plus s of naught. G is the force acceleration due to gravity, and that's that negative 32. It told us the initial velocity was 64, and it told us the initial position was 80. So if we just plugged everything in and we simplified that, we get negative 16t squared plus 64t plus 80. Now on a test, I would need you to do the calculus to get here, to get all the points. And that gives us the exact same answer though. So you could use your pre-calculus skills to check yourself. Alrighty. That's all we've got. Try the homework. Whenever you get to numbers 35 to 41, look back at this example here. I think it would help you. And good luck, and I'll see you all on Wednesday.